Solving quadratic equations by completing the square. Now, the bell work that we just worked hopefully reminded us of a foundational skill here. Foundational skill here for solving quadratic equations by completing the square is solving quadratic equations using the square root property. Okay? I think these first few examples are going to help us to do that. The square root property, this is lesson 105. No, 104?
105. You said we're skipping 104.
No, we're doing 104, and we'll cover 105 tomorrow quickly. We're skipping 106 and 107. Thank you. Before we learn the technique for solving quadratics, we have to know the square root property. The square root property we just covered says that if x squared equals b, then x equals plus or minus square root of b. Okay? It's a foundational property for using the square root property. All right, completing the square. The plus or minus is the key, guys. If you forget that plus or minus, you miss out. And recall that the plus or minus comes from the square root of x squared is actually the absolute value of x to protect the definition of the absolute value symbol, and the absolute value of x being the square root of b means x is plus or minus the square root of b is where we get the plus or minus from. Okay? That comes from the property of the square root having to be positive. All right? So, if x squared equals 25, what is x?
Positive or negative 5.
X is plus or minus 5, exactly right, right? Plus or minus the square root of 25 is plus or minus 5. All right? What about x squared equal 13? What's x equal to? Plus or minus the square root of 13. So it works whether it's a perfect square or not. If x squared equals 13, then x is plus or minus the square root of 13. It works, all right? What about this one? This is not x squared equals b, but it is something squared equals b, right?
X equals 2. Plus or minus 2.
No, not plus or minus 2.
It's 2.
2 certainly works, but negative 2 doesn't work. If you put negative 2 in there, what do you get? Negative 2 plus 3 is 1. Is 1 squared equal to 25? No. So your plus or minus instinct works. Yeah, what? Say that again? Negative 8 would also work. But how do you get that algebraically? Savannah?
Would you simplify it to be like the x squared plus 6x plus 9? Subtract 25 on both sides?
You could square the left side into x squared plus 6x plus 9, subtract 25, and solve by factoring. But we're going to go straight to the square root property, Jackson. You take the square root of both sides. Using the square root property, x plus 3 has to equal plus or minus 5. Okay? Then from there, we have two equations, right? X plus 3 equals 5. X plus 3 equals negative 5. And from those two equations, we get 2 or negative 8. 2 or negative 8. Okay? I wish. Same thing here, right? X minus 5 squared equals 36 means x minus 5 equals plus or minus 6. So x equals 5 plus or minus 6. When you add 5 to both sides,
You get 11 and 1. Negative 1.
all right, so when we solve that, we get 5 plus 6, which is 11, and 5 minus 6 is negative 1. So two solutions. Now, we could do it the other way, but it takes a long time to square x minus 5, subtract 36, and then factor it. But it would factor. You could solve this by factoring. All right, now, what we want to be able to do is take an expression that isn't a square, like we just had all squares, right? they were given to us in squared form. But what if we had to complete the square? What if we had to make it a square? Remember, we'll always be squaring something because to invoke the square root property or complete the square, we're going to square things. Move everything that doesn't have a variable to the right side. This is the process. Take half of the first degree coefficient. That's the linear term, just the x or just the a or whatever the variable is. Half of it, square it, and add it to both sides. What's going to result then is a perfect square trinomial that can be solved using the square root property. Now, as we look through this process, that's going to be the best way to understand it. And we'll kind of come back, maybe even tomorrow we can write these rules when we're going over this. Here's an example. X squared plus 12x equals 6. Now this says what number would you have to add to both sides to solve by completing the square? All right, let's go back to the last one. What did it say? It said to take half of the first degree coefficient, half of it, and square it, and add that to both sides. Okay, y'all, half of the first degree coefficient. So half of, here's my second degree term, here's my first degree coefficient. Half of 12 is 6. And 6 squared is, 6 squared is what? 36. So to keep the equation in balance, I have to add that to both sides. Right? Now what can I do on the left? X squared plus 12x plus 36 would factor as what?
X plus 6 squared.
X plus 6 times x plus 6. That's equal to 42. Then I would invoke the square root property. And that would give me x plus 6 equals plus or minus the square root of 42. I'm not going to worry about simplifying that. It won't simplify, will it? 42? No. So subtract 6 from both sides, and the solution here would be two irrational solutions. Negative 6 plus or minus the square root of 42. That's the two solutions. All right? Let's look at another one. X squared plus 14x equals negative 12. What number would we have to add to both sides here to complete the square?
49.
Half of 14 is 7, and 7 squared is 49. So if we add 49 to both sides, we get this. And when you do that, it completes the square on the left-hand side. What's the factorization of x squared plus 14x plus 49?
X plus 7 squared.
X plus 7 squared equals
37.
37. Then the square root property tells us that the two solutions here are x plus 7 equals plus or minus the square root of 37. Subtract 7 from both sides, and we get these two irrational answers. Negative 7 plus or minus the square root of 37. Irrational numbers, but they're there, right? If you wanted a decimal approximation for this, you could find it. Now, these roots are where this parabola, if we started out with a parabola here, if this were a parabola, x squared plus 14x plus 12, that's what I've found here is the x-intercepts for that parabola. Two irrational numbers. Doesn't help us a lot, but... All right, so here's a solve. This one says solve. So the first step of the completing the square process was to get everything that doesn't have a variable to the other side. So subtract 12 from both sides and skip a blank. You need to be writing this. You're behind. To complete the square, take half of 8, which is 4. Square that and add it to both sides. What would that give us? On the left, x plus 4 squared equals 4. Then we can invoke the square root property, which says x plus 4 equals plus or minus the square root of 4, which is 2. Subtract 4 from both sides, we get negative 4 plus or minus 2. Negative 4 plus 2 is negative 2. Negative 4 minus 2 is negative 6. Now, let me ask you this. Is this the best way to solve this? Is this the best way to solve this? Look at the original problem. Can't you factor that? What are the factors of 12 that add up to be 8? X plus 6 times x plus 2. If you set each of those factors equal to 0, you get negative 6 and negative 2.
Why don't we just do that?
All right, because we're practicing the process. The reason we didn't do that is because if you can't factor, we need a method to solve, right? The previous problems that we worked had those weird answers, right? You didn't write them down. Negative 6 plus or minus the square root of 37, things like that. You can't find those by factoring, right? Because they have irrational roots. And so completing the square gives us a method for finding the irrational roots of a quadratic expression. Okay? This one, if you can factor it, I would factor it. Can this one be factored? There's no factors of 4 that add up to be 6, are they? So let's solve by completing the square. X squared plus 6x equals negative 4.
Oh, yeah, negative 4.
And then completing the square process says take half of the middle coefficient, square it, and add it to both sides. So that would be what?
9.
Add 9 to both sides. And that gives us x plus 3 squared equals yo mama.
Is that really South African for 5? No!
Don't ask that. All right. So here we go. X plus 3 equals, y'all are so hard to have fun with. X plus 3 equals plus or minus the square root of 5. Invoking the square root property, subtract 3 from both sides, and we get x equals negative 3 plus or minus the square root of 5. That's two solutions, right? Negative 3 plus the square root of 5 or negative 3 minus the square root of 5. All right, we've got to do one more because I want you guys to see a little bit more difficult one. Let's do 3x squared. You ready? Three x squared minus 12x equals negative 54. Now this throws a wrench in the gears. What's off with this one? It has a x squared has a coefficient. Anytime that happens, we got to get rid of it. So we have to divide through this entire equation by 3. If we divide everything by 3, that gives us x squared minus 4x equals negative 54 divided by 3.
Negative 18.
Good. It's an integer. That's great. Okay. Then we got to take half of negative 4 and square that. That gives us what?
4.
Positive 4 to both sides. Okay. Now the left side will factor as x minus 2 squared equals negative 14. Now let me ask you, is that going to have a real solution? Can you square something and get a negative value if it's a real number? So at this point, because in this course we're looking for we're in the real numbers. We're not dealing with imaginary numbers. But these two solutions are both imaginary. We would have to invoke the square root property. X minus 2 equals plus or minus the square root of negative 14. Then x equals 2 plus or minus the square root of negative 14. That's our two imaginary solutions, which in a simplified form would be 2 plus or minus I times the square root of 14. So this one has two complex solutions. Yes, Wilson?
So if we graph this on a graph, on a plane, would the parabola touch the x-axis?
No, no real solutions. So parabolas that have a real solution. Now we'd have to go back to our original parabola, right? Our original parabola that we're working with here would be 3x squared minus 12x plus 54. If we set it equal to 0, that's the zeros that we're trying to find. That's the x-intercepts we're trying to find. The x-intercepts for this parabola are imaginary, which means they don't touch the real axis. Okay? Your homework, let's see if I can